stability in motion is important because by having a good motion or a good movement, we can actually ensure that you able to reach objective. Kalau movement yang tak stable ni, most of the time you are going to end up with something that is jagged and you are not going to achieve whatever thing that you try to have. So in sport, this one is important. To talk about stability in motion, we need to understand a term first. The term that play in mind is equilibrium. Saya belum masuk kan topik ni dengan kelas kamu kan? Dah sudah ke belum? Macam belum?
Belum.
Belum Okay. Stability. And another one is balance. Okay. To understand these two, we need to understand equilibrium, which come from the words equal. Okay, and equal here is equal in term of force. Okay, right. So let's say we have an object. If this object, the velocity of this object equals to 0 meter per second, means that at that particular moment, there are no force acted here, 0. There are no force acted here, 0. And also there are no force acted in this way. Okay, so this one is known as force horizontal. So in the case of equilibrium, force horizontal equals to 0. This one is known as force vertical, force ke atas, also 0. And this one is known as torque or rotation. Okay, so in the case of equilibrium, we can actually conclude that F net is equals to 0. No force acted upon the system at any direction. This is the first case. Or the second case, similar, FH0, FB0, torque also 0, and result also 0. But in this case, we have velocity. Katalah 2 meter sesaat. Cuma, you need to bear in mind it. At any given point of the system, bola tu, it is moving, it still move at the same velocity. Ni case kedua. Okay, this is the second case. Have velocity, but the velocity does not change. If does not have velocity, it will remain no velocity. Ini adalah konsep equilibrium, where the first case is known as static equilibrium. And for the second one is known as dynamic equilibrium. And as you may see here, since there are no changes in terms of anything, means here we are lacking of acceleration. So the state of equilibrium is a state without any acceleration, where an unmovable object will remain unmovable, a movable object will remain movable, but with the same velocity. This is as what being described by Newton first law. Itu konsep equilibrium. Okay, that is the concept. Okay, so now by knowing the concept, setelah kita ada satu objek, okay, this object does not move. Okay, it does not move. Dia equilibrium tak sekarang ni? In this condition, is it in equilibrium state?
Yes.
Yes. Okay, kita namakan dia state number 1. We put a force which caused the ball to have an acceleration. Now the ball moving. Is it in equilibrium state? Number 2?
Yes.
No.
Constant acceleration. Tak.
Pasal dia bergerak. Saya belum masuk yang ketiga. Pasal dia bergerak, okay? Because it has acceleration. So when it has acceleration, means that the state of equilibrium being disrupted. Because equilibrium here is 0. Okay? The state of equilibrium being disrupted by the presence of acceleration. Okay, katalah kita tak buat apa-apa dekat bola ni. Up until a certain time, the ball stop. Now, for the third phase, is it in equilibrium? At here, is it equilibrium?
Yes.
Yes. Okay, yes. At this arrow, is the ball equilibrium? In equilibrium state? Dekat arrow tu. Dia equilibrium tak?
Tak, sebab dia decelerate.
Yes, sebab dia ada deceleration. So whenever you have this thing, it is not equilibrium state because an acceleration disrupt equilibrium. Okay, konsep ni kamu kena faham. Okay, an acceleration disrupt equilibrium. Okay, yang itu. So now, if we have an object 100 kg and we push the object, let's say to move 1 kg we need 1 Newton. Okay, we push the object with a force of 70 Newton. My question, is this object in a state of equilibrium? Now, after being pushed. Nak gerakkan 1 kg, kena ada 1 Newton. Dia 100 kg and we apply 70 Newton. Does this object equilibrium?
Yes.
Yes. The answer is yes, because it does not move. So, why the object does not move? It's because of the mass. And this mass is known as the ability to resist. Okay, since they are mass and the mass is much more compared to the force, this object has the ability to resist disruption of equilibrium. So, this object at this moment is in a state of stability. It has stability. Okay, kenapa dia ada stability? No velocity. At the same time, no acceleration. No acceleration, tak ada apa-apa lah terjadi pada equilibrium. That is the first one, stability. So, stability is the ability to resist disruption of equilibrium. Okay, let's say the same object, 100 kg. We push the object with 110 Newton. Does this object now in equilibrium state? Sekarang, adakah dia dalam keadaan equilibrium?
No.
No, because it moves. Means that it has an acceleration. Okay, let's say the object now still the same. Moving 2 meter sesaat. 2 meter sesaat. 2 meter sesaat. Is this object now in equilibrium state?
Yes.
Yes, except ini saja. This one is in equilibrium state simply because the velocity is constant, meaning that there are no acceleration. Acceleration equals to 0. Okay, if this object is in equilibrium, is it stable now? Dekat point ni. Okay, point 2, point 3, point 4. Is the object stable? Is it or is it not?
Stable sana sir?
Stable, okay, konsep stable ni tadi, nampak? Ability to resist disruption of equilibrium. Disruption of equilibrium caused by acceleration. Faham yang tu? So now, we have an equilibrium state. In other words, this object is stable because there are no acceleration. Macam macam kamu naik bus lah, naik bus and then tak ada seat, so you need to stand up. Okay, you need to stand up holding the handrail. Bila bus tu mula bergerak forward, you are going to move backward, betul? Do you ever feel this one?
Yes.
Okay, bus ke LRT kan. Tapi, do you notice when the bus go up until a certain pace, you are no more goyang-goyang tidak. You are static. Pernah tak rasa benda tu? The bus still moving. But condition A is not equal with condition B. Condition B, stable. Condition A, unstable. Because of condition B, now there are no more acceleration of the bus. Bus tu dah jalan sama laju je, 40 je. Condition A, it is from 0 to some speed. Means that there are acceleration. So in this case, number 2, number 3, number 4, there are no acceleration. So is this one stable?
Yes, sir.
Yes. Itu konsep stable. This one. Okay, resistance to disruption of equilibrium. So your body ability to return to desired position or trajectory following a disturbance. Contoh macam kalau kita berdiri, okay, kita berdiri and then somebody push you from behind. Tapi dia push tu tak kuat, you tak bergerak selangkah pun. That is stable. However, if somebody push you from behind and you feel the force pushing you forward, which make you step forward in order to maintain standing upright, that is what we call as balance. Ability to control equilibrium. Kan, kita ada orang standing and then somebody push. First case, push, tak gerak. So this is stable because it is ability to resist that disruption. This is disruption. Orang kedua pula, after being pushed, he step forward. He step forward because he does not want to fall down. That process is known as balance. This is stable. Naik basikal. Okay, naik basikal. Saya tengok naik basikal macam ni kot. Naik basikal. And then you feel like you are going to fall to the right hand side. Apa kamu buat? Rasa macam nak jatuh ke kanan. Apa benda yang kamu akan buat?
Gerak ke kiri.
Gerak ke kiri kan. So, when you go to the left hand side, you balance up. Jadi, when we talk about balance, it is actually the process of doing this. Benda yang kat tengah-tengah pusat tu. Nama dia COG. Controlling the COG. Okay, as long as the COG falls in your, fall in the base of stand tu, you are not going to fall down. Okay, kita ada satu bila kita berdiri kan. Berdiri ke, duduk ke apa ke. There will be area which surrounding the outermost layer of your body. Contact. Contoh kaki kamu macam ni, satu lagi buka besar, buka kan. Okay. So this area from the edge of your feet, left and right, in the middle, this is known as base of support. To be stable, we are going to put our COG in this area only. If we put our COG out of the area, you are going to be unstable. Okay, unstable means kalau dekat luar ni orang tolak kamu, senang kamu nak bergerak. But if your COG here, when people push you, if the force is not enough, COG akan pergi ke depan, but yet still in the base of support, you still stable. Okay, so now when people push you, your COG falls forward. You are going to fall down. You are going to fall forward. So what you do is you're going to step forward. Means that process is going to make the COG back in your base of support. This process known as balance. Ni dua konsep. Stability and balance. It's come from equilibrium. So, in the process of stepping forward, means you're going to have a forward movement. You're going to have velocity. You're going to have acceleration. At that point, you are going to lose your stability because equilibrium being disrupt. Bila kamu dah step forward and stop, COG dah stable, and then a new equilibrium being presence. Tu konsep equilibrium, stability, and balance. Boleh? Ni konsep dua ni. Okay. Balance is the ability to control equilibrium. Kalau kita tak nampak, macam mana nak nampak equilibrium ni? Means we try to not having any acceleration. We try to maintain our COG. That is process of balance. Stability is the resistance to disruption. Maksudnya bila orang tolak ke, bila orang tarik ke, there are no change, there are no acceleration. As long as there are no acceleration occurs, you are stable. Okay, contoh macam ni kan. Kita ada kotak, satu kotak besar, sejuk ke apa ke, dengan satu kotak pensel. We push. Ni tak bergerak, yang ni bergerak. So this one, at that particular moment, it is not stable. Walaupun dia tak jatuh, but dia bergerak. Means the condition is changing. There are acceleration. Not stable. Sampailah dia berhenti kat depan tu. Stable. Okay, stable satu, new stability. Kalau dia bergerak lagi, unstable. Sampai dia stop, stable. Ataupun dia bergerak dan dia bergerak pada satu kelajuan yang sama. Stable. Okay, that is stable. Balance pula, kotak ni kita tolak. Pernah tak kamu main benda yang bawah dia ada pasir tu? Saya panggil dia bobo. I do not know what are the things you call it. Kita pun pukul dia, dia return balik. Do you ever play this one? Atau pukul lebih je berkecai. Pernah main tak? Ada yang macam telur, ada yang lebih kurang macam ni. Tapi bawah dia either air ataupun pasir. Do you ever play with this one? We punch it return. Ada tak? Pernah jumpa?
Pernah, sir.
Okay, so the process of wobbling back and forth, that is balance. Okay, dia try untuk jadi keadaan begini balik. Dia wobble ke depan. When dia wobble ke depan, COG dia pergi belakang. Wobble back down, up until the wobble rate pun makin lama makin kecil. And lastly, dia tak wobble lagi dah. Age stop. So, when age stop, this is the state of equilibrium. State of stable. This process is balance. Tu dia. 3 konsep daripada nota ini. Okay, stability, balance, equilibrium, state of zero acceleration. Where we have horizontal force is zero. Kalau kita bagi horizontal force, the object is going to move forward. If we give vertical force, the object will move upwards. Tu dia. Okay. Force tadi kan kita ada 3 tu. The object, we give horizontal force. Object move forward. Kalau kita bagi dia vertical force, object move upwards. If we combine these two, object move like this. Tu dia. Okay, it move macam ni. Ke atas dan ke depan. It depends on which direction of force is larger. If the horizontal force is larger, you're going to get something like this. If the vertical force is larger, you're going to get something upwards. Vertical force dia lagi banyak daripada horizontal. Lagi banyak. This one, horizontal lagi banyak daripada vertical. Kalau horizontal dengan vertical sama-sama banyak, you're going to get quite a nice projectile. Okay, ke atas value sama besar dengan ke depan. This is force. As long as you have this one, not in equilibrium. Okay, not in equilibrium because there are acceleration which cause projection. Okay. Next one, in human body, when we talk about balance, we are going to talk about lever. Okay, bila kita cerita equilibrium ni, kita akan cerita tentang lever. This one. So in human, we try to make ourselves balanced so that movement is under control. Okay, movement is under control. Okay, saya keluarkan yang tu. So the most simple form of level in human is our hand column, okay, where the elbow will serve as the fulcrum. The weight that we try to lift up or bring it down is known as the resistance, and the force being generated by muscles which attach to the attachment point, okay, force. This is an internal force, example of internal force, muscle contraction. So kamu akan ada tiga. You're going to have force, you're going to have fulcrum, you are going to have resistance. This is basic level. Okay. So for lever, another thing that play a major role is the moment arm. Okay, we have two moment arm. One is known as force moment arm. Another one is known as resistance moment arm. Okay, to make thing balance, or equilibrium, force moment arm will always equals in term of value with resistance moment arm. Jadi mana moment arm? Okay, moment arm is this one. Kita cari fulcrum dulu. When you try to find out moment arm, please find the fulcrum first. Okay, so from the fulcrum up until the point of force, this is known as force moment arm. So as for resistance pun sama lah. In the middle of resistance to the fulcrum, this is known as resistance moment arm. Okay. So contoh lah, kita nak buat penggunaan ni. Let's say this item is 100 Newton. So how much force needed in order to make this system balance? Okay, so you have force moment arm equals to 3 cm, and then resistance moment arm equals to apa panjang tangan lebih kurang 40 cm. 40 cm. So how much force needed to make this system balance? First, this one kena tukar jadi meter dulu. Okay, pasal kita measure nanti Newton meter. So kita ada force kali dengan force moment arm 0.003. Resistance we have 100 time with resistance moment arm 0. Selajak perahu ke? 3 cm. 3 cm lebih kosong. Betul ke? Saya salah? 0.4. Berapa dapat? How much you get it? 1240 over 0.03.
Satu, tiga, tiga, tiga.
1333 sikit sangat ni. Okay, 1333 Newton. Nak balance 100 Newton ni. Kenapa? Because of shorter force moment arm. Okay, so kalau kata kita ada objek force moment arm yang lebih pendek daripada resistance moment arm, in order to move that object, force needed is higher. Ni konsep dia. Jadi kalau kita nak bergerakkan barang, kita nak gerakkan barang dengan force yang sedikit but heavy object, you need force moment arm yang lebih panjang daripada resistance moment arm. Due to that, we have 3 different level lah, where the first level is something like this: fulcrum, force, resistance. Second one, we have something like this. Fulcrum, resistance, force, and the third one balikkan je. Fulcrum, force, resistance. fulcrum. So the first one is quite a balanced system where we have FA equals to RE. In here we have F larger compared to R, and in here we have a shorter F compared to R. Dia sini nak tunjuk the placement, okay, the placement. Okay. Contoh macam ni. Okay, macam ni. Dalam badan kita kat mana kita boleh dapat this kind of level? R in the middle. Kat mana? Tu, R in the middle, second class level. Where in our body we may have this kind of level? Dekat bahagian mana? And where in our body we can have this kind of level? Kat mana? Kat mana? Second
Kat
class.
apa tumit boleh sir?
Okay, tu mate, kelas ke berapa?
Saya second class.
Second class tu mate. Okay, kita ambil gambar tu mate kaki. Dan kita ada feet. So dekat bahagian sini. Which part will serve as the fulcrum here?
Jari kaki.
Jari kaki jadi fulcrum. Okay, this one will be fulcrum. Beban. Resistance here it will be our body weight. Force ke mana? Force will be dekat mana?
Dekat tumit.
Force dekat tu mate. Nampak macam kartun. So force dekat bahagian tu mate je lah, tak lawa. Saya kaki. La ilaha illallah. Yeah. Okay. Fulcrum will be here, so to mate will serve as the force. So beban dia sini. Ya ke macam ni? Oh. Nampak macam tak ya. Fulcrum, force, resistance kat tengah. Yang kita lukis, resistance. Okay. Untuk kita tahu force tu datang pada mana or dekat mana, we need to know which muscle contract. Baru kita tahu force tu datang kat mana. So kalau macam yang ni means most of the time when we talk about lever, fulcrum in our body will be the body joint. Jadi kalau kata tumit ni kan, if we take kaki as an example, like this, okay, most of the time, this will serve as the fulcrum. And we have muscular contraction from the leg, which will pull our leg upwards, meaning now the force is here. And this will serve as the resistance. Fulcrum, force, resistance. Yang mana tu? Fulcrum, force, resistance. This
Third
is
class lah kan?
third class. Jadi kalau third, dia kita kena tahu kelas tu pasal benda ni ya. When we talk about second class and third class, it define the action or it define the function. As for the second class level, most of the time it's favor power, because here we can see force arm is longer than resistance arm, meaning we need to use only a portion of force to deliver outcome compared to the third one where it favor speed. Tapi when force arm pendek, we need to use a lot of force in order to get similar effect as second class level. Okay, contoh macam ni kan, kita buat satu kira-kira dia. Katalah kita ada force 200 Newton and force arm 0.0 5 meter. Objek pula, okay, let's say kita ambil resistance arm 0.15 meter. Okay, how much resistance can this system lift? Apa berat barang yang dia boleh angkat based on the new information here. So kita ada resistance arm yang lebih panjang daripada force arm. Okay, so we have F, FE, R, RE. F 200, FA 0.05, R kita tak tahu 0.15. Jadi R equals to 200 0.05 divide with 0.15. Berapa dapat?
66.67.
66.67. 1/3 je daripada force yang kita ada. Means by using 200, we can only lift up this. So now let's change. Okay, let's change. We change FA ni dengan RE. Thus, berapa kita dapat? So now the FA is going to be 0.15, the RA 0.05. Berapa new R yang kita dapat? R equals to
600.
berapa?
600.
600. 0.15 bagi dengan 0.05. 600 Newton. By using only 200 Newton, we can lift up 3 times compared to the original weight. Ni beza RA dengan FE. So when you try to work later on, you try to have a good or a very high outcome. If the system involve lever something like this, first thing you need to bear in mind is the length of moment arm, because this determine output and usage. So if you want more output, make sure the force arm is longer. Time tu lah kita pakai equipment lah. Contoh macam kita main hoki ke apa kan, tapi tak pakai equipment ni lah. Kita main golf. Now kan ada foot golf kan, which you are not using golf club anymore. Okay, kat sini kita kena tengok length. The difference of length determine the difference of moment arm. If foot golf length is shorter compared to the original golf, means that you're going to use more force in order to get the job done comparing with playing with the club. Because of moment arm day. Force being produced is similar, but the moment arm determine the outcome. Okay, to lever. Okay, that is lever. Right, so I recall back, we have 3 type of lever. First class, fulcrum dekat tengah. Force and resistance in between that with quite similar force arm and resistance arm. Second class lever, resistance in the middle, making resistance arm shorter compared to force arm. So this one, we can move heavier object easier. And the third one is force in the middle of resistance and fulcrum, making the force arm shorter. So when you have a shorter force arm, the action will be faster, but you are going to use more and more energy to have the same amount of result. Ni 3 class level. Okay, this is the 3 class level. And when we talk about equilibrium, based on this 3 class of level, what we are going to have is actually the term mechanical advantage. Benda sama je, jangan sakit kepala, benda sama je. Okay, jangan sakit kepala dengan gambar ni, where you see fulcrum in the middle. Don't ever bother by this, but always seek FA and RE. When we try to explain about mechanical advantage, we are going to explain about moment arm. Okay, moment arm. Right. So if we have something like this, RA yang panjang, FA yang pendek, at the end of the day, you are going to get quite a large ROM. But the drawback is you need to use more force. Comparing with if you have FA yang panjang, although the ROM will be shorter, okay, the ROM will be shorter, yet you need a small amount of force to move heavier resistance. Ni macam kita kira tadi. Okay, jadi kita ada 3 mechanical advantage. This is known as, if you end up dengan benda macam ni, sama, this is known as mechanical advantage 0. Okay, where force arm and resistance arm at the same length, stable. But if you have something like this, force arm is longer than resistance arm, this is known as mechanical advantage 1. Less force, more resistance. And this one is known as mechanical advantage -1, where you need to use more force to move a lighter object. Tu 3 mechanical advantage. Okay, 3 mechanical advantage, and these 3 mechanical advantage only applicable in the case of lever in order to achieve equilibrium. FA equals to R, RE. Okay, sampai situ dulu. Ni pun kita dah bincang tadi. Static equilibrium, dynamic equilibrium. Static equilibrium when there are no movement at all. Dynamic equilibrium means there are movement but in constant velocity. No acceleration. Here pun no acceleration. So equilibrium is the concept of inertia. Newton first law. Okay. Sampai situ dulu. Ada soalan? Any question? Boleh dapat tangkap? Ui, senyap Tanya soalan, ada soalan pun sangkut Okay tak?
Tak ada saya, tak ada.
Okay lah tu maksudnya. Right.
Okay.
So if okay, this will be the last part. So kita tak perlukan recording lah macam ni. No, sorry. Means we can explain everything, we can discuss everything, and I'm going to post all recording. So kamu tak perlu belajar sendiri macam tu. Last part is regarding center of gravity, and when we talk about center of gravity, it has a direct relation with the first concept kat depan tadi. Stability and balance. So if you are stable, you don't need balance anymore. Pasal kamu dah tak perlu nak control shifting of those COG when you are stable. Okay, now is when you need to control the balance. So the thing that play in mind is your COG, a point around which a body weight is equally balanced in all direction. Okay, so kita kembali semula kepada benda yang paling penting in COG is this one. Base of support. And we have, usually the COG will be located in the middle of our base of support. Okay. Calculator ni. Right. So, when we move, the COG will actually move bila kita bergerak. And at that point, you are not stable because there are tendency for you to fall down when you move. Okay? As long as the COG is in the base of support, that problem will be minimized. Yet, it's still in motion. Ni macam ni kita bergerak kan, COG tu dia akan bergerak, naik turun accordingly. Although you feel that when you walk forward or you walk backward or you walk sideways, the belly button is at the same place. Yet, the dynamic of our motion will ensure the COG to have a fluctuation. Dia akan bergerak atas bawah. And to maintain stability of our body, there are several factors which play a role. Okay, the first factor is mass. Ni benda sama, ni benda kita bincang awal-awal tadi. The first factor is mass, berat. Kenapa berat jadi punca stability? Okay, we compare 3 box. Tengok orang mungkin tak faham compare box. First box is 100 kg. Second box is 50 kg. Third box is 10 kg. And all of this box being applied with 70 kg of force. Yang mana yang bergerak? A, B, C. If 70 kg of force being applied to these 3 boxes, which box will move? A, B, C. Yang mana bergerak?
C.
B dah gerak? B 50?
Gerak.
Gerak. So bila gerak, dia ada apa? dia ada
Acceleration.
acceleration. When there are acceleration, the object is not stable. Tu je. When there are acceleration, the object is not stable because acceleration cause movement. Movement disrupt equilibrium. So when you have a case of disrupting equilibrium, that is a case of instability. Jadi A lagi stable berbanding B and C because of the mass. Macam ni lah. Orang macam ni kalau kita tolak, compare dengan orang macam ni, compare dengan orang macam ni. Siapa bergerak dulu antara tiga ni kalau kita tolak? 1, 2, 3. Who are going to move first? Cikudut lah, gerak dulu. Nombor 2. Si mesum ke si bulat?
Shadow.
Macam sama je saya bentuk dia.
Macam sama tu lah, macam sama. So kita kena assume dia lagi berat lah. Kita assume dia lagi berat daripada si shadow ni. But if the shadow is at similar weight as the bulat, same amount of force needed in order to move them. Jadi lagi banyak force kita guna, okay, more force we use in order to move an object, that object is much stable compared to less force being used. Contoh, kotak dengan bola. Bola kita tolak satu jari, dia dah bergulik. So bila dia bergulik, dia acceleration, not stable. Kotak kita tolak satu jari, dia di situ. Okay, one of it is because of the surface. Okay, itu yang pertama, body mass. Yang kedua, surface. Baru cerita surface, bola dengan kotak. Okay, if we have 3 object, macam tu, kita ada objek 1, 10 kg, objek 2, 10 kg, objek 3, 10 kg. Now the mass is equal, but we have different surface of friction. If the mass is equal, the larger surface of friction cause more energy needed. So this is much stable. Tu konsep dia, kita nak guna energy. Lagi sikit guna energy, barang tu lagi tak stable. Pasal sikit dia perturbation, it move. Okay, so if this one, the hierarchy will be 1, 2, and 3 because this use less amount of energy in order to make it moving. So from unmovable to moving, dia melibatkan acceleration. Okay, kenapa saya kata begini? Okay, ni konsep. Let's say kita ada bola ni lah, bola ni. Alright. This ball being applied force, which cause this ball to move at V equals to 2 meter per second. And this action occurs in 1 second. Maksudnya, tolakkan tadi 1 second, cause the ball to move. Okay, now let's see what we have. We have V2, 2, V1, daripada tak bergerak. T, 1 saat. So, acceleration equals to 2 minus 0 over 1. 2 meter per second square. When there are motion, there will always be acceleration. When there are acceleration, it's not stable. Unless, okay, ni masa kedua kan. Okay, masa ketiga dia pula, still 2 meter sesaat. So we have masa 1, kosong, we give force, masa 2, 2, and we just leave it there. The ball keep on travel at the same velocity. 1, 2, 3. So kita tengok yang ini pula. Acceleration equals to V2 minus V1 over T. This is V2. This is V1, this is V2. Pasal ni kompleks baru. Kalau antara dua ni, this is V1, this is V2. Antara dua yang ini, this is V1, this is V2. Okay, katalah perubahan ni terjadi dalam another second. So we have V2 minus V1 over time sama dengan kosong. So when the acceleration, when the velocity is equal throughout the place, there are no acceleration. When there are no acceleration, that is stable. Dynamic equilibrium. Tu dia. Okay, so this is the second factor affecting stability. Surface friction. The third one is base of support. Okay, the third one and the fourth one is about base of support. Okay, so konsep dia macam ni. Base of support is the outermost layer, the surrounding area from the outermost part which contact with the land. Kalau kita berdiri macam ni. Kalau kata orang tu pakai tongkat, so dia ada kaki, dia ada tongkat yang cecah lantai. And the outermost layer of this contact is base of support. Kalau orang tu yang pakai tongkat 4 tu. 1, 2, 3, 4. So the outermost layer of all, that will be base of support. Ni konsep base of support. Now, if you try to be stable, increase the size of base of support. Satu. Yang kedua, if you try to be agile, decrease the size of base of support. Dua. Yang ketiga, if you try to be stable, make sure the COG lies within the base of support. You are going to be stable. But if you want to be agile, contoh 100 meter sprint kan, nak laju pergi ke depan, make sure the COG is outside of the base of support. In other words, stable sampai bila-bila pun tak boleh kawan dengan agility. If you try to be stable, you are going to be slow. If you try to be agile, you are going to be not stable. At that point lah, bukan throughout the point. At that point, at that instant. Ini konsep dia. Okay, next one. How we want to increase the stability of us is by putting the COG in the line of force. Contoh. Okay, contoh. Kita main rugby. Tackle. Somebody tackle you from side. Okay, let's see. In order to move the COG out of the body, it require movement such as 10 cm. Okay. Pada tengah pusat ke ujung 10 cm. 1 cm, 1 Newton. So to move this, you need only 10 Newton. Okay, now imagine this. You know that your opponent coming from your right, from your left. So what you do is, you already prepare by push or move the COG, means kamu dah lean towards the person who are coming to you. So you are leaning means you are going to put the COG here. Kita dah leaning siap-siap ke arah force. Now, instead of just 10 cm, dia dah jadi double. 20 cm. Means that instead of 10 Newton of force to disrupt your equilibrium, now he need 20 Newton. Lagi banyak force diperlukan, lagi stabil kamu. Tu konsep stability in terms of base of support and the placement of the COG within the base of support. Ensure that you are stable. And the last one is the vertically positioning of the center of gravity. In other words, the lowest the center of gravity, the much more balance you're going to have. Okay. Okay, macam ni. Contoh bila force ni dia bagi dekat sini, force dia bagi dekat tengah, and then force bagi dekat atas. So this one is going to use more force in order to make it fall compared to the third one. Ni maksud dia. So the lowest COG you are going to have, the lowest placement of the COG, make sure you are going to be much stable compared to if the COG is at the higher point. Alright, so that's all for equilibrium. Any soalan? Ada apa-apa soalan?
Sir, yang point number yang friction tu kan, tak faham apa yang bola yang selukis kan. Dia
Ni. Okay.
Yang
Alright. Bola dengan kotak ni, bila kita ada surface friction yang besar, okay, right, kita akan ada coefficient of friction. Do you still remember this? Ke saya ajar kelas lain ni? Kita ada coefficient of friction. Satu static, satu dynamic. Okay, satu static, satu dynamic. So, the larger surface friction, the larger surface in contact, the larger static friction. Contoh. Barang ni semua 10 kg. 10 kg, 10 kg, 10 kg. Okay. Now, kita tukar dia jadi Newton dulu. This one is going to have roughly around 100 Newton lah. 10 kali 10 kan. Okay, katalah this is quite large. Static friction coefficient dia 0.7. This one, static coefficient friction dia 0.5. Ini yang paling sikit contact. Static coefficient friction dia ialah 0.2. Now,
Sekejap sir, coefficient ni apa sir?
coefficient ni dia adalah numbers which represent something. Dia selalunya bila kita buat kira-kira, coefficient dia akan bagi. Dia ada pengiraan dia lah, dia akan bagi. Okay. Friction kita ada dua. Static coefficient, coefficient masa benda ni tidak bergerak. Do you notice macam kereta kan, bila kita cuba untuk tolak, berbanding dengan kereta tu dah bergolek, kita tolak, berat dia berbeza. Do you notice that? Kereta rosak ataupun kita nak alih almari kan, mula-mula nak tolak susah gila. Tapi when we start to make it move, it become easier. Do you ever happen at that particular condition? Pernah tak kena benda macam tu?
Pernah sir, pernah.
Okay, so at the point of starting tu, that is known as static friction because there is no movement at all. And when the object start moving, kamu tetap ada friction in between the surface of that almari dengan floor. That is known as dynamic friction. Usually, if static friction is something like this, dynamic dia rendah. 0.5. Dia akan kurang berbanding dengan static. So this static friction determine how much force needed in order to move. Okay, because the total friction here, the total force we have here is force time dengan dia punya tu, coefficient dia. Okay, jadi force 100. Berapa coefficient dia? 0.7 kan? Okay, 100 Newton kali dengan 0.7. Kita dapat apa? How much we get here?
70.
70. So this 70 is the friction. So how much is the total force we have in the first box? 170. 100 berat box, 70 friction. 170 means in order to move that, we need at least 171 lah. Barulah dia boleh bergerak. Kalau kita bagi 170 juga, dia bergerak tak?
Tak.
Tak. Okay, now yang kedua. We have the same 100 but the friction is 0.5. So you end up dengan 50 plus the weight of the object. So kita ada 150 Newton. Means in order to make this move, we need 151 Newton. Nampak? Lagi kecil daripada yang atas. The third one, 100 kali dengan coefficient 0.2, you end up 20 plus the weight of the object 120. Means in order to move this object, we need 121 Newton. Lagi kecil daripada yang atas. So lagi kecil force, macam yang kita belajar mula-mula, lagi kecil force diperlukan untuk make the object move, the object become less stable. Ni kaitan antara surface friction with stability. So the more surface friction you have, the stable the object is going to be because it requires much more energy to disrupt the equilibrium. Okay.